been doing a great job for us as our chief test pilot and our chief military test pilot on SCOBAL airplanes. Just to recap for you, sort of the background on the program, this is the first time I've been able to show you 3 real pictures of 3 real airplanes as opposed to PowerPoint presentations in the past. But the family of 3 airplanes, each designed to operate optimally in the takeoff and landing environment of the service that it's going to fulfill its operational duties with, by capturing economies of commonality and scale across the 3. And I think Grant will tell you, and Steve will tell you, if you sit in the cockpit of any one of the 3 airplanes, they're exactly the same. Same stick and throttle, same displays, same sensors, same engine, a lot of commonality across the 3 platforms. Different, but they need to be different to withstand the operating environment of the takeoff and landing regime for the 3 different services in the U.S. We do put a fancy tail on the first of each variant, and after that we go with the plain gray, but this is how we've outfitted the 3 airplanes so far. We do have a growing partnership. I'll talk a little bit more about that as we go through this. The original 9 countries are still very much involved in the project. A couple of them are preparing to join with our test pilots and become part of our operational test team. And we have some additional countries now that are starting to emerge with high interest in the program, so I'll cover all that. So it's a great chance for me to come back and give you an update on the project, and we'll press on. I've got some video footage that I'm going to start with. If you go to the next one there, Joe. I'm going to narrate this as we go. This is our factory in Fort Worth, but look at this as just one indication of the global infrastructure that's being recapitalized in the defense industrial base. This is a mile-long factory. We have put about $1 billion worth of investment in tooling that allows a much higher level of precision and automation and motion-based production system. This is the first time we've tried to do a moving line on a fighter-type airplane. While moving lines are fairly common in the commercial world, it's not been done on a small, densely packed airplane like this before. We bring the 4 major assemblies into the facility in Fort Worth. We put them into this mate and alignment system that you see there, very flexible tooling. Allows us to build any one of the 3 airplanes in any position on the line. Once we have structural integrity, we move the airplane to the moving line, which is shown there, where we complete the rest of the systems installation and systems checkout as the airplane is moving down the line. So the rate at which it moves will increase as we increase the rate of production. When we get to 1 a day, which is where we project the program to be in about 5 years, we'll move at about 51 inches an hour. It's not fast enough to really see, but it's fast enough to get a statement of work done. A lot of robotics. You see the robots there applying the coatings to the airplane. Those coatings have to be applied very precisely because they do add weight to the airplane if they're applied thicker than they need to be, and the human application of those coatings tends to not be as precise as we do with the robots. You can see the robots there applying the coatings to one of the airplanes. We do fly the airplanes first in what we call green, so if you see a picture of the airplane, it looks kind of turquoise. That is the chromate-based primer. You can see it on these airplanes here as we go down the flight line. All of our STD jets are now out of the factory and on the flight line. 8 of the 12 current flyers are flying. The other 4 will fly by later on this year and delivered to the test site. So very active period of time. Inside the factory today, if you go back through the moving line and the maintenance assembly station, those are all production jets now. They're both from L1 and L2. So that's the manufacturing piece. Best way to summarize it is that we're not just recapitalizing the multi-role fighter force of the U.S. and our coalition allies, we're also recapitalizing the defense industrial base around the world on this project. Okay, the next piece of video I want to show you is kind of an update on flight tests. Just the nomenclature, AA-1 was our very first airplane. This airplane has now been retired from flight test, and it's a live fire test article that's out of China Lake right now. We'll start doing live fire testing here soon. We did a lot of risk reduction. Obviously, you see the weapons bay doors. We flew this airplane supersonic. Our very first supersonic flight had a full combat load of weapons inside the airplane. We're able to do some unique testing like field arrestment testing for the Air Force version of the airplane. We're also able to do jet blast deflector testing for the Navy airplane with the Air Force version because the length of the airplane is the same and the engine's the same. This is our STOVL jet BF-1 on the ramp. Back in the days when we were measuring forces and moments. We've now got 4 of those airplanes at Pax River. This is BF-1, the first airplane that Graham flew, arriving on its ferry flight into Pax River. The very first full mission system airplane is the airplane we designate BF-4. is now at Pax River also flying as actively in the test program. We have a shot here, just a second, of some of the short takeoff and short landing work. Both styles of in-flight refueling, both the Navy probe and drogue and the Air Force system, have all now been qualified on the airplane. Of course, the big activity at Pax River is just having lots of airplanes on the field. It's been a while since they've had that there at Pax River. I'm doing some of this very interesting testing. This is a Stovall conversion in flight. Most of you, I know, are familiar with the doors. There's 8 unique doors on this airplane. The second set behind the big 57 Chevy hood is the aux inlet door that allows air to come in and feed the main engine when it's in a hover. This is a short takeoff, I think about 800 feet of roll on that one. We'll now start building down as we start expanding the envelope by restricting the amount of roll the airplane takes on takeoff. And this is 18th of March, I believe was the day. I had the privilege of standing on the runway when this was happening, and this is Graham putting the airplane down in the first vertical landing. I think I'll tell you that it was a very straightforward, very easy maneuver to do. There's something about a supersonic stealthy jet landing in the vertical mode that sort of defies the imagination of most of us. The third version of the airplane, the Navy variant CF-1, this is Jeff Knowles, our former F-14 pilot, Navy test pilot, flying that airplane. You can again see the non-chromate primer on the airplane. We don't put the full coatings on until we've flown it a few times. I think in the debrief, Jeff said this was as close to a perfect flight as we've had. We started up, took off, flew an hour, hit every test point on the cards, came back and landed, the airplane was ready to fly again. So again, showing some of the maturity for a first flight. We've had a number of first flights on the program. I think this one generally went the smoothest. You can see the bigger wing on this airplane, additional wing, outer wing panel there to allow the airplane to slow down for landings on the ship. It's our first Air Force version. We do have 3 of these airplanes flying now. The third one is a full mission system equipped airplane flying in Fort Worth. The first 2 ferried out to Edwards Air Force Base a while back in a formation, which was kind of neat to send 2 airplanes out at once. This is their flight. They did tank en route, so we did qualify the Air Force in-flight refueling system when we did that. This is the 2 of them coming into the field at Edwards Air Force Base, the dry lake day down there. And they've been, they entered right into productive flight testing. I think they flew a day later, the first flight, and they've been flying regularly since then, so we're expanding that envelope. Another unique airplane is the Cooperative Avionics Test Bed, or Catbird. This is the airplane we're testing our mission system sensors on right now. I'm going to show you some imagery that we're capturing off of those sensors later on in this presentation. But in essence, it's an F-35 flying in the body of a 737. It replicates the F-35 exactly in the way the sensor layouts are done. Okay. Another